it's first discovered. In this case, it shares two places. I don't know how to say most of those words, so that's why I put them up there.
Give it a shot.
Nope.
Right.
You first.
So in 1852, fluorite was named, when it was discovered, for the phenomena of being able to fluoresce. Most of us already know that. It doesn't put my reader's notes up for me to see, so I have to try and remember what it said because they go away. What causes most of the fluorescence in fluorite is rare earth elements. That's what's missing. So that's thorium, uranium, cadmium. So a lot of the rare earth elements that are on the periodic table are in trace amounts. Parts as small as it's supposed to be 1,000 parts per million. So very few. Other causes of color in fluorite is natural radiation. Usually is what causes it to be black. A lot of the really vivid azurite blue stuff coming from China now is pale fluorite that they've irradiated to make them that vivid blue. It's very pretty. So I'll show you some here in a minute. Crystal defects in the crystal can also cause color. So. Blue fluorescence is caused by europium, which is one of the rare earth elements. So whenever the rare earth elements are in there that cause the color change, it's replacing the calcium, not the fluorine in there. Red fluorescence is caused by samarium and gadolinium. Yellow is caused by dysphorium, terbium, europium, or a combination of the three, or two, a combination of any of those three. Yellows can also be caused by the presence of hydrocarbons inside there, especially the ones from Illinois. You'll often look at them in natural light and they look waxy. That's because they have oil trapped inside of them. Sometimes there's enough oil in there that you can see in hydros of the oil moving. You can see the bubbles of it.
Wow.
They're really cool.
Where do you get one of those?
Not for me.
You don't have one?
I do not have one. Pale yellow to white. I tried doing white up there, but you couldn't read it.
Go figure.
Go figure. So almost always the pale yellow and the whites come from limestone type deposits. Clay Center in Ohio is famous for those. And the inclusion that's in there is organic material. Green fluorescence is caused by ytterbium, there we go, which is very rare. Very, very rare. Chlorophyll is defined as blue-green thermoluminescence. Thermoluminescence, so when we put a UV light on a mineral and it glows, that's called fluorescence. Thermoluminescence, as you can imagine, is caused by heat. So if you heat it up gently, it's going to glow this blue-green, and that is caused by, I don't know what it's caused by, but it's called chlorophyll. Unfortunately, it only usually does it once.
Let's go.
It almost never does it a third time.
Wow.
So there's a number of habits. This is the shape in which you see fluorite. So if you look at a quartz crystal, you can imagine there's all kinds of different shapes quartz crystals come in. Fluorite's the same way. You can have a cube or a form of a cube. You can have an elongated cube. You can have needles. You can have spheres that form naturally. There's over 100 different fluorite habits. They're almost always a derivative of pressure and temperature. Sometimes the impurities can cause it to be different shapes, but the pressure and temperature is almost always the driving force. Some people collect just fluorite because it has so many different habits and so many different colors. I have a friend who collects three things: calcite, fluorite, and pyrite. And his fluorite collection is phenomenal. Fluorite also is it's named after, also gets part of its name due to its fluorine, and which is what's causing part of the formula, chemical formula, calcium fluoride. Romans prized it for carving. So did the Chinese. You want to try and say that? There you go. In either spelling.
Vikranta?
That's it.
Vikranta? I don't know.
Vikranta.
So, fluorite forms mostly in late crystallized minerals with felsic igneous rocks, typically through hydrothermal activity. So, felsic igneous rocks are going to be your granites that are lacking quartz. So, which is a felsic igneous rock. Otherwise, we just call it granite. So, you get these, and here in Utah, we have a couple of these deposits where you get the Topaz Mountain. You get a lot of fluorite at Topaz Mountain. The Tiffany stone, not the Tiffany stone, but the other fluorite that forms down there forms as like this. And then there's a place down in Ryan's Creek, which is down in San Juan County. You can't get to it from the Utah side. You have to go into Colorado and then come back into into Utah from that side, because there's no roads that go into the mountain from this side because of the river. And so you get there, and there's this big granite intrusion, and there's these big seams of fluorite that formed in those intrusions. And they're really cool, and I'll show you a sphere of that here in a minute. What's really neat about that is that I'd never even heard of this deposit or even anything in this area. And this geologist that he and I had words a couple of times, and now we're really good friends. And right. Well, he was mad that I was collecting someplace that he didn't think I should be collecting. And I was like, it turns out I was okay. And he was wrong at the time.
A geologist admitted he was wrong.
No. But he gave me permission to collect everything.
No permission to collect.
Well, by then he did own the property, so. But anyway, so Maria and I go down there, and we take some friends that live in Grand Junction, and we go down there. And there's a mine that goes underground, and it opens up into a room, and you can see the hanging wall and the foot wall. And the hanging wall is the wall above the fault, and then the foot wall is where you're walking. And it's got, I don't know, 2 or 3 inch seam of beautiful fluorite, bright green. And I'm like, I don't know how you're going to get any of this off and keep any of it. It's just going to crumble. And sure enough, you look at the ground, and it's all fluorescent blue because it's all just crumbled all over the ground.
Mm-hmm.
So we go looking around the side, and what's Maria to do? She climbs up, and she's, oh, look here! And she's got this nice foot-thick seam where she's pulling out big plates of all crystallized fluorite.
Yep.
Yeah, that's a surprise.
Right? So it was a fun place to collect.
Oh, look, an alien. I'm waiting for that one.
It's coming. So it can also form from hydrothermal activity. This is hot fluids that come up from the ground and deposit there, which I think might be what snowflake is a hydrothermal.
Yeah, so's the one down in New Mexico.
He
In fact,
owns-
it's in a hot water area. So.
Yeah, he owns a couple of fluorite claims, so that's why he should be teaching this actually. 3?
Oh, that's why I take you to them. I've got 4 now.
What
4?
about-
Wow.
Greedy.
What about the one down by Milford?
Let me think that through. They're in a hydro.
Is that hydrothermal?
No, it's not hydrothermal. They're going to be in the felsic granite because they were actually in granite. So yeah.
Okay.
What about the Norman mine up by, is it Brigham City?
Yeah. I'm going to say it's probably in the felsic granite, but I'm not 100% sure on that one. So I haven't been to that one in like 25 years. All right. Fluorite can form in sandstone. Usually it's found as the cementing material that holds the sand grains together. Instead of calcite, sometimes it's fluorite. Common associations with fluorite are galena quartz, calcite pyrite, barite, salarite, chalcopyrite, and rhodochrosite. All of these can be found with fluorite in Utah. Epitaxial minerals. Epitaxial is when you have a mineral growing and another mineral grows off of it, but they share the same crystal structure. So there's not a crystal structure change. So in this case, it's almost impossible to figure out exactly where it's at because the atoms are literally intermixed. And so we see this with hematite and rutile. You'll have hematite growing a blade of hematite, and you'll have rutile needles that come off of it. That's epitaxial. So in this case, in the case of fluorite, these minerals here grow epitaxial to it. Largest fluorite crystal in the world, it's been measured, weighed 16 tons.
Oh.
Wow.
Yeah.
cube, huh?
20 centimeters across, so what is that, 18 inches? No, 14 inches?
And 7 feet long.
The largest one's 7
Oh.
feet.
Yeah, I'm sorry. Almost 7 feet long across. Weighed 16 tons. The biggest fluorite crystal I've ever seen is a cube that was about this big.
From where?
I think it was from Russia too. Might have been from Missouri. I'm not sure now. The guy that I talked about that specialized in fluorites, he owns it.
Was it a good, clear crystal with phantoms and everything, or was it just
No,
ugly?
it was
That makes me feel
gray
better.
green.
Yeah.
It's only impressive because of its size. So the gangue means waste rock. So fluoride's often found in the gangue minerals, especially in veins. So that's why we find it on a lot of dumps, the mine dumps. It's because they don't want it. They didn't have any use for it. It wasn't pure enough to use as a flux, so it couldn't be used for anything like that. It literally is the definition of the hardness number 4. If you use the Mohs hardness scale, it literally is number 4. Industrial uses, most of it is used for flux and smelting. Also used in producing a lot of glasses. Borosilicates is mixed in with that. It's often mixed in with regular glass because it will remove the impurities as it cooks out.
We used to use that at the uranium mill down in Moab.
Mm-hmm.
We were also going after vanadium.
Mm-hmm.
Vanadium is a lot harder to get out, so we had a very strong acid leach.
Mm-hmm.
And we threw a little fluorspar into it, which turns hydrofluoric acid. And that stuff eats anything.
Literally.
Yeah, Colorado mine, the literature we found on it said it was acid grade. That's what they were using. That's what they were mining it for. The snowflake.
Really?
Yeah.
Wow. We're going to have another talk about that in a minute. All right. We've already done this. All right, so here is when I talked about the crystal habits of fluorite was temperature and pressure. Here's a chart that shows where you get as the temperature comes down, where the crystal shapes form. Rapid cooling versus slow cooling. Temperature versus the shape of the crystal. You get the octahedrons at the higher temperature. Pleochroism is the property that a mineral exhibits when you look at it from different angles and its different colors. Fluorite is one of the best ones that does that. So you can look at one crystal face and it's blue, another one is purple, and another one is bluish green. It's used a lot in lapidary. We like to cut up pieces for jewelry. I used to have a bowl like that. I can't find it. So specific types of fluorite, you have rainbow fluorite. Blue John fluorite is stuff that comes from England, from the Blue John mine. And it's quite pretty. Most colors, most of the time it's named after its color. Well, it's blue fluorite, or purple fluorite, or blurple fluorite, that's blue purple. I made that up.
Blue purple.
You can have phantom and zoning, so you can have a crystal that has one color in the middle and a different color on the outside. Now, if the darker color is on the outside, then you can't see the inside. But if you have one that's got a dark blue on the inside and a lighter color on the outside, you can see the phantoms in them really quite nicely. Famous locations around the world, pretty much everywhere. These are some
consequences.
these are some of the big ones here in Utah. The Dugways, Milford, Ryan's Creek, Bingham. Bingham produced a lot of fluorite back in the day. They don't produce much anymore because they're too deep. The Deer Trail Mine, Rush Wellman, that is where we get the Tiffany Stone, and Grant Peak. Grant Peak is on the Dugway Proving Grounds, and it is used as a target because it's bright white, and they can see it from really high, and they know where to shoot their targets.
Is it off limits, is it?
A little bit.
Unless you're real quick.
Cave Mine, I will show you some from there. And then minerals, it can be an inclusion in other minerals, calcite and quartz. And I have one here that has a quartz crystal that has fluorite cubes in it. And David Horman has found down in the Mineral Mountain smoky quartz that has clear, distinct fluorite cubes inside of it.
Crystals inside of it.
Yeah, they're not like smudges. They're perfect little purple crystals.
Yeah.
We brought him over and he goes, I can't believe this would be fluorite. And I said, that's exactly what this is. So,
Wow.
all right. Now we'll do the show and tell. That's the perfect reaction. All right, so I kind of have these in a little bit of an order. I'm not going to pass all these around. Some of these are just way too valuable to pass around. You can bring your chairs in here now. Okay. And so here's the quartz crystal I was talking about that has fluorite cubes in it. You can just go ahead and look at those. Am I holding these up to the camera?
Yeah, please.
Oh, that's cool.
Oh, that's cool.
This one too.
Oh, it adds twice as much time. All right. This is the blue one I was telling you about that has been irradiated. So it was probably, you can see around the bottom here, you can see the greenish, grayish colors, and they irradiate them to get them these purple colors. This was not a cheap specimen, and I bought it because it had been irradiated. So I can show people. I'm going to pass these ones around in the box.
Is that the black fluorite?
No, it's dark blue.
Oh.
You'll see it when you get there.
Is the black really rare?
I don't know that it's rare.
I've never even heard of
Most people
black
just don't
fluorite.
collect it because it's black.
Yeah.
It's another black and
Is
ugly.
that coated or
Oh,
is
that's
it all the
cool.
way through?
I don't know. I don't know.
Did you see that stuff Austin Hartman? Or not Austin Hartman, Chris. had
Oh,
his
yeah,
booth
uh-huh.
With the green,
Yeah.
once you put the, yeah,
Yeah, those are cool. That's the
I got
fun to
one
me.
of those.
All right, this is one I collected a couple years ago from Austin's claim. You've got the fluorite, the feldspar, and the smoky quartz. A nice little combination piece.
Wait,
Start
wait,
over this
wait.
Oh,
wait.
sorry.
And
What?
we should go that way and then back.
Well, I
See
don't
it
know.
back here? Or?
We haven't seen it.
So that's from Colorado.
Here's one that shows zoning. You can see it well if you hold it up the light.
in the cheap seats.
You can see.
Got to reserve early.
Yeah, you have to look at this one a little closely. You've got purple over yellow, but between the two is a layer of chalcopyrite crystals. It's like somebody just sprinkled dust in there, glitter.
Hold it up, hold it up.
Look at the crystal shapes. Here, I'll let you pass.
That's cool. That's a cool piece.
All right, here's a rare
pretty piece.
association. This is a fluorite, and it's got many hoppered faces on there. That's what we call when a crystal terminates with multiple types of terminations. And but this has got malachite growing over it. Also zoned quite nicely. I should have turned off the music.
It was nice.
This is another
Keeps me calm.
interesting combination. This is a quartz crystal. I'm sorry, not a quartz crystal, a scheelite crystal growing with the fluorite.
It's cool. You can see the yellow and
Oh, that's cool.
Okay, did you?
a Cuban.
Where's that one from with the shoelace?
It is from China. So here's some botryoidal fluorite.
That one.
So this
Oh,
instead of
cool.
growing cubes, grew as bubbles.
Those two on the end. Let's see.
We've got botryoidals that are like this big.
We
Wow.
haven't shared.
Coming out of your
It's in
mind.
it's in the one, we've only opened that mine up once. Oh, it's at the snowflake. We call it the Lost Chadwick, because Chad found it.
All right, here's one that was
Oh, look.
pretty impressive. I'm going to pass this around the box.
That's
Try not to handle this one a lot. This is a really super dark purple fluorite over yellow. This is from a very rare location in Germany.
It's not black, huh?
Not if you hold it up to the light. It's approaching black. I already passed one like that around. This was one from Clay Center, Ohio, that we talked about. The fluorescence white. That's an exceptionally large cube.
Yeah, that's cool.
Ooh, that one's pretty.
This is from his topaz claim?
No, I'm sorry, that's not from
That's
his.
George's.
That's
isn't it?
George's, you're right,
Okay.
you're absolutely right, that's George's.
I was gonna say, we don't have anything on that side of the valley.
No, you are absolutely right.
For once, okay, did everybody hear that? That is the first time in 50 some odd years he's ever uttered those words.
Yeah, you're right.
That'll be the last time too.
Yeah, I'm sure. It was worth the wait.
This is from the Dugway Mountains here in Utah.
That's cool.
Yeah, just. This one is a neat one. This is a bunch of octahedrons stacked up together. This is from China. They kind of have an interesting peachy color to them. This is one of those ones that's super valuable.
So let's not pass it around.
Well, just be gentle with it.
Catch it on.
When I say super valuable, I mean it cost me like $1,000.
Grand more than I have.
This is one I just recently acquired from a trade from some guy that had no idea what he had.
Some guy.
Just
I knew what it
traded
was. I just wondered what you had.
So, that one's from Mexico, right?
Mhm.
Yeah. All right, this is probably the most
one's
valuable
so
one
pretty.
here. I'm not going to pass this one around. This is from the Shambo mine in China. It's on dolomite. All the white glitter is dolomite.
And then I'll give that to you, and then you can.
That's what I'm doing. I handed it to
No,
you.
I mean,
Maybe we might
instead
put
of
it
you
in our
looking
pocket
at
and
it,
take it home.
give it to me. Oh, cool.
It's a zombie, it'll come with you.
Okay. This is another one from the Dugway Mountains here in Utah. Green fluorite mixed with some quartz.
That's a pretty
It's
one.
a fluorescent blue.
Probably.
Ooh.
Ooh, ah.
You've seen it.
It's like you've seen that before.
They'll probably
I've
sell
seen
it to
this
you.
one.
Brains. I've seen
You already
the
sold it
brains.
to me.
I know.
I traded that for a little rock.
All right, this is one from Terry's Claim in Colorado.
Ooh, pretty.
Called the
Ooh,
Snowflake.
that's pretty.
Ooh.
It's
Oh,
opalized.
Yeah. So it does have
That's
opal mixed in with
cool.
it. So fluorescence.
Yeah, just
fluorescence yellow
opalized.
and then some is blue.
It's mixed with opal.
Really?
Yeah, it's similar to Tiffany stone.
It's
but it
opal
doesn't
light,
have the blue trim.
not like colorful opal.
No.
No.
Well, they in the geological survey they said they had found precious opal on that mine,
Really?
and I have been everywhere
Yeah.
on that. Every
Somebody was
inch.
drunk when they wrote
I
that.
think you're probably right.
So this is a slab. This is the kind of stuff you see in jewelry a lot.
Yeah.
So it's translucent behind
Oh,
it. So make
yeah.
sure you hold it up to light to see it.
Often made with plastic if it comes from China.
And here's a faceted stone of the same material.
Ooh, pretty.
Oh, pretty,
Yeah.
That's been polished.
Just now put that.
yeah.
Isn't it cool?
All right, so the stuff from Ryan's Creek, this is it. This is the sphere. And if you look, you'll see little flashes of galena crystals that got polished that were mixed in with it.
Where's
And
Ryan's Creek?
it's the one down in San Juan County that you have to go to Colorado and come back in. The pin for it's in the book
I'll
if
let
you
you
want to
take
go.
that.
So. But it's a good hike, and you're not going to get your vehicle
So
down there.
weird. That is that.
I damaged my truck pretty significantly.
Yeah, pretty.
All right, and then there's several Utah fluorites here that are just kind of large, so I'm not going to pass them around. And then that one is from the Blanchard mine in New Mexico, very famous. And
10 miles away from ours.
Is it really?
Yeah. Well, maybe it's 20.
That's the one on the end here.
In
That would
fact,
make a
ours
pretty
was. It was founded by Blanchard Hanson.
sorry.
I don't know if it's the same as
Probably.
the Blanchard that, or he was Blanchard, New Mexico was named after him.
So here's a
We don't
Tiffany
have
stone.
it.
This is a nice purple one. The purple one here is
The galena. Oh,
the
it's
fluorite.
okay. See the
Some of these
galena in
actually
there?
are lined
You've
with
got my
little
hand
tiny
in there.
fluorite
Yellow
crystals.
and green. That's great.
So in Tiffany stone, the purple is the fluoride?
Uh-huh.
Oh,
Yeah. So Tiffany stone is an interesting material. It is bertrandite clay, which is a beryllium clay, and they just form as these white pods in the ground. And if the groundwater carries in the fluorite, and sometimes the opal, and sometimes the manganese, you get the Tiffany stone color, the purples and stuff. It's named after the guy who brought it to market 50 years ago. He named it after his wife, whose name was Tiffany.
Tiffany.
Yeah, and
It's all about the marketing.
right. It's all about the
Yeah.
marketing. She was cute. She probably still is cute. I don't think she's dead. Anyway, so everybody thinks that Tiffany stone is this unusual thing. It's not really. They're not bringing any of it to market. Anything that you find out on the market was basically stolen from the mine because they will not let any of it out, and so the miners would sneak it out. And honestly, I'd go down there on a weekend and I'd pay the guard $100 and he'd help me fill my truck. I came back with 1,000 to 2,000 pounds. I don't know, probably 5 times in one summer. And
You are being recorded.
The
a long
operator,
time ago.
well,
He was
the
fired.
operator was eventually shot, so.
Yeah.
Oh,
they
okay.
executed him,
So
so.
what happened is they got into this new chemist in there, and he was like, "We're not letting any of this out. Beryllium is toxic. It's deadly. We're not letting anybody have any more of this stuff." And he's right. Elemental beryllium is extremely toxic.
But not
In the
in-
form of an oxide, it has no effect on you whatsoever.
It powers spaceships.
Exactly.
Wow.
So,
Galaxy Quest.
Galaxy Quest and
Beryllium
Beryllium
spheres.
spheres.
Yeah.
They're miners, not miners.
All right, yeah, that's
Great
another one
show.
from
Yeah,
Twilla.
I love
This
it.
is from the cave mine. All right, so this is a fluorite that's coated with quartz.
That deer trail.
Deer Trail mine, yeah. So the Deer Trail mine in it had to be the early 90s, started producing these and bringing them out to market. And they were all covered with this layer of quartz. And here it's I don't know, less than a millimeter thick, and it got to several inches thick. And this guy here in Salt Lake, mineral dealer, went down, worked it out with the mine to buy all of it. And so he had all of it, every piece except for a handful of them that made it to market. And yeah, just throw them on the floor. And he was cleaning them in his backyard. He was cleaning that quartz off with hydrofluoric acid. He went and bought a couple of drums of hydrofluoric acid, which is probably the most caustic acid you can possibly get. I mean,
So that's where the hollows came from?
no. And so when he was done cleaning them, they looked like this. Now, everybody likes that green color.
Yeah.
And so what's funny today is this is more prized because
Absolutely.
the mineral collectors or the mineral dealers don't want to deal with the hydrofluoric acid. Oh, this is much better to get it with the quartz on there. BS. I'll take this any day. This was $150. This was $1,500.
Wow. Wow.
So this dealer, this mineral dealer, is cleaning these in his backyard with hydrofluoric acid, not having a clue as to what he's doing. And so he went and got some Rubbermaid containers, the really shallow ones, and he filled it up with a couple of inches of this hydrofluoric acid, and he was putting them all face down there, dissolving the quartz. And it takes a day or two to dissolve that much quartz off of here. Some of them longer that had more quartz on them. And he had been doing this for months and months. And so all these open containers of acid in his backyard, the vapors were drifting across the grass, killed all the grass, killed all of his landscaping, went in the neighbor's yard, killed all their landscaping and their pets, cats and dogs, and another neighbor, and then it wound up in a cemetery where it killed everything that was
In the
already
cemetery.
dead. And old growth trees, it killed everything. It killed birds and
Wow.
it was just killing everything, but he didn't even realize it. And the only reason it became a thing is because he splashed them on his arm.
Oh.
Well, hydrofluoric acid doesn't burn you when it gets on you because it kills the nerve endings. But it will burn. It will.
Oh,
It will
keep going.
dissolve your flesh until it hits bone, and then it dissolves your bone and it kills the marrow inside your bone, which is why it's so toxic, so deadly. Because you get that enough on your arm, you're gone. And so he woke up in
Oh,
the
no,
morning with all these
hydrofluoric.
burn holes all over his arms. So
Sorry.
he went to the doctors, his doctor, and his doctor was like, "What in the world?" It's like it looked like he'd taken cigarettes and burned holes in his arm, but really deep, like a half-inch deep. And so he told his doctor, "I think it's hydrofluoric acid." Well, his doctor was his neighbor, and so he put it together. What was going on? He's like, "You've killed everything." So the lawsuits went into the millions. So he didn't make any money off all this fluoride.
Oh, man.
He could have possibly sold enough to make up the lawsuits. His homeowner's insurance paid for most of it, I know, but anyway. So now in Utah, you're required to have a permit to have hydrofluoric acid, and part of that, the permit is you have to have a reason to have hydrofluoric acid. It can't be mineral cleaning.